Kia ora koutou katoa. Welcome to RaC Guild Townhall number 16. This is the first Wednesday in the month of October. It's spring is springing in New Zealand. We are really pleased to welcome Thomas Gorissen for a repeat performance. I wasn't here for the last RaC Guild Town Hall, but I'm looking forward to the run through that you're promising for us today. I think there'll be time for lots of questions after your little demo, Thomas.
Yeah.
So without further ado, we'll go straight into it. Hand over to you. Thomas Gorissen from Legalese.
Thank you, Joe. Good to meet you too.
You're welcome.
It's still pretty early. Like, I only woke up like 15 minutes ago, had a coffee. Should be good, but just as a warning. All right, I'll take over your screen then. I hope this will fit quite well. I'm trying to do this all on a bit of an unusual keyboard today because my other one died somehow. So I hope it's going to be okay. So, like, this is technically a little bit of an introduction to coding for, I guess, legal drafters, which most of you are. And I keep it very basic to functional concepts here. You saw the demo with Matt last time where we had this kind of propositional logic, and you could sort of define what we call functions in IT in a way that the result type is always Boolean, like it's either true or false. Right. So you would implement all kinds of different functions where the result would ultimately turn out to be true or not. So you're checking like attributes or conditions in order to make sure that something complies or doesn't. And the visualizer that we created for this that Matt likes to show is kind of the useful part to this because it allows you to drill into nested functions and visualize that. Now, I want to go a slightly different path here and show how when I get like a task from a potential customer to implement a policy or even legislation sometimes, and Michael, good to see you too. Like, I actually thought I'll show in the final minutes of this the child order that we did for the Ministry of Manpower here in Singapore. They have a bit of text that defines like what determines that this is a firstborn child or a secondborn child. And so I thought that would be quite interesting from the perspective of implementing it as software, right? Which is a bit of a different use case. So Matt's use case comes from a legal drafting perspective, and how do I get a tool that helps me drafting and getting confident that the logic I implemented actually represents what I wanted by giving you the visual tools to confirm that, drill into this, play around with it, create kind of these scenarios where you can say, you know, this should be true. Is this true? Now, so I give you a different perspective on L4 today. L4 is a functional programming language built on Haskell. It can do what we did with the dog act. No, was it not the dog act? Yeah, the dogs and sheeps of Matt last week. But this time it's more about types and functions and a few IT terms that you might not be familiar with. Not many. It's pretty easy compared to other programming languages. Then it's not a subjective statement. So we start with the basic building blocks of L4. So what you see here is a function, like what we call a function. I know in legal it has a different meaning, but in IT this is a function, and it is one of the syntaxes that L4 has to implement a function. There are others, but this is probably the most memorable one. It essentially says that this function called adding it up expects two arguments. One we call A, the other one we call B. We define them as the type number, so we expect it to be something numerical. And in this, like given these two arguments, adding it up means adding a plus b. So this is the implementation of the function, which is indented. So it needs to be moved in compared to the function name a little bit. And it just said, okay, you add them up, like do the math with it, right? You could do a normal plus sign too if you fancy that. And then L4 gives you the tools to then try this out. By calling eval in the editor or writing it with a hash in front and then naming the function name, you can now say 2 and 4. So you're passing 2 and 4 as arguments into this function, adding it up, meaning 2 becomes A and 4 becomes B, and A plus B is now returned. And so if I hover this, I get 6. So it actually runs the function, right? So that is the foundational concept in a functional programming language, is the idea that you can define functions that have arguments, and like you can be explicit here as well, give it a number, because what that means, it's the return type. The return value is also a number. It's expected to be a number, right? Meaning when you add two numbers, you expect another number. That's what we're saying. So this is the very basic idea of what a function looks like in L4. Again, there are many different ways to implement them, and they can take slightly different shapes if you really go into it. But this is the very basic idea of it. Then we have a few base types. And so types are sort of descriptors for value. Number is a base type, right? A numerical value. Like it can be a decimal, it can be an integer. I think it can even be a percent, which essentially just takes 100th of it. So this should be 4.025. There you go. So you can add 2.5% to 4. Fantastic. So it's a numerical value. That's what number defines. What won't work here is if I say true, right? So true is not a number. True is a Boolean. And so now the LSP shouts at me and tells me the first argument of function adding it up is expected to be of type number, but here it is Boolean. And it's like, okay, well, you did something wrong, right? So that, like another thing, base type is a string, right? Which you use with the quotation marks. And here it would probably say, oh, but here it is of type string, right? Now, a fun concept that when you read L4 code on the internet might be confusing is something that programming languages do for a long time. It's called type inference, meaning that on evaluation, meaning when I execute this little function here, that the language LSP can actually infer the type, right? So when I was able to leave this out, I was able to not define that the function returns a number, and yet somehow it still worked, right? Because the language itself was essentially looking at everything and was like, well, I have 2 and 4, which are numbers. I have to add them up mathematically. Well, the return of that is a number, so I presume that the return will be a number, right? So that's called type inference, and it does it automatically. The same way, I actually don't need to say given here necessarily. But I need to tell it that there can be 2 arguments. Then there can be A and B, but I could write it like this. So adding an up A and B means A plus B. This is exactly the same thing. It still produces 6. It's a slightly different syntax. It just means that the function adding an up has 2 arguments, A and B. Again, it's technically the same. It's just that the types of A and B are now inferred, right? So they were inferred by the fact that I passed 2 and 4, right? If I do this, it would say like, oh, you know, because here is I add them up, they need to be number, and true is not a number. So it does the same thing. This is just something to understand, that they not always have to be explicitly mentioned. They can be inferred from the context. So it's more up to the person implementing it on how explicit you would like the language to describe what is happening. This is an option because sometimes you have types that build on each other, and it doesn't really matter which of the 2 you pass in. And so you can leave it open, and then it would expect both if they fulfill whatever other requirements. But that gets already very complicated. It's just for understanding, whenever you see given and giveth not being written, it doesn't mean they are not there. Another syntax that we have is decide is, which does the same thing. It's just a different syntax that gives us more like options to the drafter to say, I want to use a different language here because means is not my style, right? But it does essentially the same thing. It adds 2 and 2 to 4 here. This is the function name now. These are the argument, and it works with given here as well. I could go back and put given up here as well. So now you already understood the most important thing about L4, functions. Great. And you have base types. The base types are number, Boolean, and string, right? So the most useful ones for you are probably Boolean and number. But this is that. Now we can define more complicated types now that are not base types. So we can implement complex types however we like, right? And in the context of L4, we most often do this to like maybe I'll copy something in from an example now that I would like to choose later. Let me just find it really quick. No, it's already pretty complicated, but I'll do this here. So and we don't have the date yet. Well, I can. So the import date is a library. Oh, because okay, now I need to go back to the specific implementation again because date overrides something. Anyway, I delete this for now. So import date is a library that we wrote that gives you basic functions to work with dates and days, so that I have a type date now that is available to me that wasn't available without it. And so I essentially can say eval August to 2025, right? So this is now a date of the 2nd of August, 2025. So this is an additional functionality I just imported. Now this type, a birth event, now I say has 4 attributes. And so you can see how this is useful because I can contextualize and say these attributes that I have here really describe a larger object, a larger thing called a birth event, right? So they together make the birth event or are relevant to a birth event. And they are of date, Boolean, and Boolean, right? And then I can start working with this type later on, and I can literally pass it into functions the same way. And then I could say the birth event date, typing date of birth. Yeah. Let's say at least where am I wrong? Number, Boolean. Well, I would like date and date. How about that? Sometimes I can use these parentheses to give more context to it. Maybe I want to give it Boolean for now. Okay. I have a number string, from date to date, but that should work, no? Hey, let me just double check that we didn't deploy a bug. Yes, this seems like pretty legit. Nope. Well, I'll do it then another way and say, all right. Birth. Okay, of course. No, I'm stupid. All right, it's too early in the morning. All my fault. What I did wrong here, I choose the type definition. Classic mistake. What I should do, I said here A is a birth event, right? So I clearly need to work with the one that is given to me as part of the function. Duh. So I need to say A's date of birth, right? I should maybe give a better name here and say the birth event in question, right? And then I can use this variable name now to put that here. So that makes more sense. So that means when I later want to run this function, calculate child order, which doesn't make sense yet, but hopefully will later, like it expects an object birth event to be passed into it when you evaluate the function later, right? Which I'm not doing right now. I'm just defining what the function means. I'm not running it. So that means I expect an object with these 4 attributes. And when then the code runs, it will check that the birth event that I passed into this function has an attribute date of birth, and the value of it should be at least February 20th, 2025. To finish this example up, I can now say calculate child order, my little function here, and now that wants to have a birth event, and I can now say I want here the argument to be a birth event, and then I use a simple syntax here, say January 4, 2025, and then true, false, false. I need commas. So this is a short syntax of defining like an object birth event. Now I'm saying I want to have a specific birth event, not the type. I don't want to describe what a generic birth event looks like, which I declared at the top. Now I want to create a specific birth event. And this is the short syntax to do this, where I can say a birth event, and the first argument attribute date of birth is January 4th, 2025. Is multiple birth is true, is stillbirth is false, and child has passed away is false. Now I can make this vastly more explicit, since this is maybe it doesn't read that nicely. And I can say I want to have this birth event with the date of birth is January 2025, and then I say the is multiple birth, I should stop doing that, is true, then is stillbirth is false. So I can make it very explicit here. Oh, that was required. So that will also work. And now you can just see that it's vastly more explicit. It tells me here I create a birth event with these particular 4 values for the attributes that are defined as date, Boolean, Boolean, and Boolean. And here I now set specific values to it, right? And obviously this doesn't read very nicely either. So I could take this birth event and say, I want to create a variable, like, you know, this is like my sister's birth, whatever. And I say my sister's birth is a birth event with the following attributes. And now I can take this variable, my sister's birth, and pass it to the function calculate child order. And I can see that like here I get false as a result, because January 4, 2025 is not at least February 20th, 2025. So now you're all programmers. Congratulations. And you have understood functions and types. And from here, you can use these building blocks to really create incredibly elaborate constructs that allow you to not only implement the rules, but to also run them, right? To really throw examples at it and see what comes out at the other side. So it's like as if your legal text came to life, right? And you can define and then see what comes out at the other end of it. Now, I give one more example because it's used in the full implementation where I replace this birth event. Whoa, it was a bit more than I wanted. Is a birth event. What do I do now? Well, so this is used in the example, so it doesn't apply in this particular case to the implementation here, but it essentially says that there's now a new type called child event, and it's what we call the group type. So it can be one of the following types, right? And it can be a birth event or a Singapore adoption application or a dependent pass issuance or a foreign adoption, right? So meaning there are now 4 type options for a child event. Just maybe unfortunate naming in this case, but so now if I go to the full example, you should start to make sense of this, which is, you know, rather elaborate. And I can also give you the text that this was based on for reference, because that might be something you're more familiar with. Let me do this here in a comment. So, move this away. So this is literally from the website. This was how the Ministry of Manpower here in Singapore defines the child order rules, where the biological child's date of birth or the adoption child's formal intent to adopt date is on or after. I mean, this is pretty long. I should have maybe enabled line breaks or something. Just so that you can see this a bit better. So then there were some references here and an example given at the bottom as well to just tell people a little bit easier on how they can work with this. Maybe just for context, I'll do that too. So this is the original text, and like an implementation that makes this text useful, and the usefulness comes from the fact when it's implemented in code, you can run the code the same way we ran the functions earlier, right? So you can now like think up specific examples, lists of events and attributes, and you can throw them into this function and see what the actual child order is, right? I can see like, oh, this is like if I have like a list of events of the following, then the child order is 2 or 4 or whatever it might be. And so this is the implementation for it. We define a few constants, we call them, or key dates. They're labeled here. That means they're important dates that are used throughout the implementation, and it's November 1st, 2021, July 1st, 2017, October 31st, 2021. And then we have the type definitions, the one that you just saw here. Then we have a child type. It's either one of these. And so here we have a subtype as well called the subject child, which is, so this was quickly generated yesterday with a new model that came out yesterday called Sonnet 4.5 that I wanted to try. So I have not written this manually, so you can argue with a lot of the naming, which is most commonly what I spend most time on changing to make it more like the source text. Because whoever wrote the source text will probably have to review this afterwards to be sort of correct and in spirit of what it was supposed to be. So like using variables and phrases from the source text in the naming of your variables and types is very useful to like find that reference again in the source text. And then like here we have a helper function, which literally just gives you the length of a list. That is something we should probably abstract away. Somewhere on the very bottom. This is technically something the language already gives you, but the AI didn't know about it, so it implemented its own, which is, you know, how AI goes sometimes. But here we now see that here is a propositional function which returns a Boolean. Is event valid for counting, right? So the idea here is that you have an event of the type child event, which was one of those. It's either a birth event or adoption application or dependent pass issuance or foreign adoption with a reference date. And if you want to include stillbirths for this evaluation, right? And then it will consider this event and text which type of event it is. Is it which one of the fours that we defined is the case here? And then different rules apply, right? So it like must be the reference date given, and so on and so on. So it's essentially the same idea. You have a function that you pass in specific types and out comes a return type. And the logic is implemented in here. There are a lot of parentheses here. A lot of them might not even be necessary. I think they can sometimes be necessary when you have and or being mixed to show the order of priority. So things in parentheses, it's like in math. If it's in parentheses, it has a higher priority over other code around it. And here's the function we are all interested in, which is calculate child order. And here you have the child in question, the subject child, and a list of all the events that occurred. And then it will go through and say if the subject's date of birth or FIA date is at least the cutoff date for new rules, then count valid events. This was the helper function it implemented to just see how many events there are. And this is a function call. This is the count valid events function. If I say go to definition, it's defined here, and it means 1 plus the length and then filters some events out. Again, already vastly more complicated than it needs to be. I would have written this much easier, but it works, so it's hard to argue with. But like, again, legal drafters, you will probably tear this apart left and right, because for you, the importance of the language is much more important. For my context right now, the fact that it can run as code is the most important thing. And then the language is something we can sort of refine to make it human compatible as we go on. But it's much easier to start from working code that already produces the result that you want and then refine the language than it is to like write the right language, but in the end it doesn't work. So that's why this approach may seem unintuitive to you, but it is intuitive if the outcome is you want this to run. You want to throw examples at it and you want to see what the outcome is, right? And then that is to verify that your code actually works. And like, here's the fun part where you can actually test this. And we create a mother A subject child. It's a biological child, born on December 1st, 2021. And then we have 2 events here. One is a birth event with the birth date January 1st, and then true and false, I think, were the parameters of it. Specifically, date of birth is multiple birth, is still birth, child has passed away. And then we have a foreign adoption event that followed. And then we have the list of events, meaning we now like make a list out of both of these events. We queue them up, if you will, into a list, and then we pass this list, mother A events, into the function calculate child order with the mother A subject child, right, which is this child, and outcomes 2. So that is, this subject child would be considered number 2, right? And this is running the code. And then here are a bunch of just tests implemented where you can say, okay, what happens? Here's a biological child, same birth date, right? But it's only one event here, right? So it's mother B event is just the birth event without a foreign adoption. What comes out of here? I think that's something I want to review why that is too. Number C, different test, and so on and so on. There might be a bug in the code somewhere. It's always 2. Fun. So this is how you can learn and work with it to figure out that it was actually implemented correctly. I have a separate implementation of it as well that I know might be working a bit better. You can see the same idea. You have the key dates. You have, wait, that's the one we just looked at. No, it's fine. And here you have, instead of subject child, it's called the current child, right? Which I would, again, language is something I would refine. And so this is a slightly different implementation. It was like, I generated it briefly last night with the help of a different model that like has a different slide of a preference on which syntax to use. And it has a different method to count qualifying events. But it also has a calculate child order function, which essentially goes through the same ropes. It considers different types of children and then implements the logic as it found relevant. And the test examples here are maybe a bit more interesting. You have a twin birth event, you have an adoption event, and then it calculates the child order for these. And here you get different results for the different expected outcomes. Normally in our line of work, we would then verify this, throw a lot more test cases in it to make sure we didn't make a mistake, make sure the code is really readable, and then we can deploy it as a system and we can make it available, and that can inform a online checker website where a mother can then figure out if he or she, if she is eligible for maternity benefits or something, and that website then queries this code to figure out what the child order is. So the idea here is essentially, it goes back to the core of what L4 was. Yes, it still is very technical a language, right? But it is a language a computer can run, and with a bit more effort from the drafter, it can be a language that is still incredibly readable for humans, more so than a typical programming language. It is built out of these very basic types, very basic building blocks, types, functions, and the ability to run the code in the end. They come with a different syntax. The function syntax is means, or decide is, with given and giveth and all these kind of fancy keywords. And the evaluation is eval or assert or other like syntax you can use to run the code in the end. So I'll leave it here because this is already quite complicated, but it just shows you how these things can come together and how you can slowly think yourself through to read L4 code and follow with your finger sort of how it is being executed, how each function sort of runs on its own, takes its arguments, and then can check specific values of these arguments to be the way that they're supposed to be in order for this all to make sense. And then you can test and run the code in the end with example cases. So I'll leave it here and open it up for questions. Let me know how much sense this all makes for you, how or if at all that might be relevant in this specific form of use for your line of work. I know Matt had opinions to it, and he thought this was all way too complicated and we should stick to propositional logic, and I know he has a case with it. That's why we sort of implemented the other way we talked about last time with a visualizer and so on to help you more from a drafting perspective. But I think for us, the more important use case was that we can run the code because then it directly translates to impacting, right? It takes like a layer out, if you will, between drafter and impact, right? So it's like, imagine you change a bit of code and you hit save and suddenly the legislation is changed because it's implemented differently now on the website, right? Meaning the child order is now a different one because you changed the code to it. Obviously, you want to have an approval process in between, as every good jurisdiction has. But it's kind of just making this a bit more streamlined. And when we talk to our private customers, insurances, and so on, they're typically very interested in that because it's sort of an efficiency idea behind it. All right. Thank you very much.
Thank you, Thomas. That was awesome. I learned something about coding.
Yeah. So like that's the biggest takeaway I wanted to put, like on what are types, what are functions, and how do you run it. The very basic building blocks of programming, functional programming, at least. This is a subset of all programming, but L4 used it because it allows you to create these almost sentence-like looking constructs, which are quite readable for people that don't know coding yet.
Absolutely, and very important for legislation. I am keen to see the other example that you were talking about, the legislation one. But let's take some questions first. Philippa, do you have a question?
Yeah, thanks, Jo. Thanks, Thomas. Just wanting to know, and hopefully I haven't missed it, but I just wanted to really confirm that obviously, first of all, you were showing us manually putting in code in terms of how the code editor works. Yeah. And then you mentioned that this code here has been generated by AI.
Yeah.
So is that AI within the L4, or is that?
So it is a tool that we have created, but it is not something we have made public yet. So we use it internally, for our purposes. There is a small demo available where my favorite, if a car has 4 wheels, its driver must wear a seatbelt before driving. So this might take some time because AIs today are not trained on L4 as data. So we sort of have to teach the AI in this process of generating the code on how to code L4 code, which is a tricky idea, but it works almost like you do it with a human. You tell it about types and functions and syntax examples and allow it to look up something up in the documentation and try to run the code and fail and try again and so on. And eventually it'll figure it out. And so this is a tool that we use to help us create drafts, right? And this comes from the workflow idea that once we have code running, it's much easier to change the language to make it really understandable and reflect precisely what we want it to mean, but it already works, right? So now I can open this, and it created a vehicle safety rule where it implemented a type car with a number of wheels, and a driver, which it gave a name, so it personified the driver a little bit here. And then it declared a safety action, wear seatbelt before driving. And here it goes already into testing a little bit. So it created like an example car with 4 wheels, an example driver with the name John, and a 3-wheel car with the number of wheels 3. And then here's the function. Now that you know the syntax, there's a seatbelt requirement function, which when you want to run it needs a car and it needs a driver. And then it returns a complex type in L4 called a provision, which always has an actor and an action. And so the actor is the driver and the action is a safety action, which is probably the only one defined, called wear seatbelt before driving. And then if car's number of wheels equals 4, then party driver must wear seatbelt before driving, right? And here you see a different way to run code, where you can throw, like every line here is an event. And so you can say, give me the current state of the seatbelt requirement for an example car and example driver at time 0, and you get an action now. You get the party example driver actually does wear the seatbelt before driving at 1, right? All right, great. Requirement fulfilled, right? Now, if I would not have this event, I would now get the next obligation that the driver, the actor, has against this requirement. And so for this car, the example car with 4 wheels, the party driver must wear seatbelt before driving, right? So this is now the next open obligation that needs to be fulfilled in order for this to complete entirely, right? And you could even make it, if you say driving is an action here as well, you could say within 0, hence, and then party driver may Let's call it drive. It reads better. And I need to indent this properly. So I have a problem here. My trace. Oh, because I still need to do that. All right. So here I'm in breach because I wear my seatbelt at 1, which I should have done at 0. All right, and now I may drive. So if I now say party example driver drive at 1, this should be fulfilled, right? Yes. But if I do it the other way around, if I would say I drive at 0 and I do not wear a seatbelt, then the party driver must wear a seatbelt before driving within 0. So this is, I still have my obligation here. Actually, I need to do this more specifically. If I drive at 0 and wear my seatbelt at 1, then I might be in breach as well. Yeah, provision breach, party driver of John who did action wear seatbelt at 1 surpassed the deadline, meaning he didn't put in the seatbelt in the right order, right? So you can sort of, this is the kind of different way of doing L4, which is provision based. And for a 3-wheel car, you get fulfilled anyway because it doesn't apply. All right. Anyway, so back to your question.
No, I think that answers. Yeah.
Yeah. So this is how AI can help us create a draft, and then we can start refining it, because it's much easier to code L4 if you have working code and you just need to edit it a little bit and move a few things around than to write it from scratch all the way.
Yeah.
Julie, you have a question, though?
Yeah, I'm just curious, like in your perfect future world, like how do you see legal drafters interact? Like, do they go and throw something at AI to create the code first to test what, you know, the legislation they're drafting, and then they test it, and then they actually sort of put it into human readable language after that? Like, how do you see sort of the workflow? Or does AI then take the code and actually puts it into human readable language in the end? Like, how do you see it all going? Like,
the criteria that we had for L4 when my colleague Meng kind of invented it was that it was composable by AI. So it should be a language that should be easily like composable with the AI as a sort of an assistant. It should be like auditable by humans. Right, so you should be able to have the code very readable and easy to understand and easy to edit and modify, so that you can audit it as a human and make sense. It's in the spirit and what you want it to be, and then it should be executable by machines, right? So that the code can be run by computers very efficiently and with precision, right? Which is the opposite of what AI mostly does today, right? So that's why we use AI as a tool to help us code, and then we run the code, because then we can get the best of both worlds. We get the benefit of AI to help us draft and think through everything until we get to the result that we desire. And then it becomes very efficient to run the code, which is like reading ultimately, or executing the legislation. Now, how in a perfect future this would be applied, to be honest, it would to be seen to a degree, right? We definitely know that there are use cases where today governments and businesses spend a lot of money to hire consultants to implement whatever policy or terms or legislation that they have come up with for whatever use case, from their security policy that needs to implement it in infrastructure so that their systems comply with security requirements and all that kind of stuff, or in a legal drafting environment. I mean, it's sort of the same way, just a more elaborate bureaucracy around it, but it's as legal drafters, you have a responsibility that's pretty large, actually, to not make a mistake when you write, or accidentally put in consequences that weren't defined or weren't in the original spirit of what was decided, right? So there's a lot to it. So ultimately, for now, we see this as a tool to help people become more confident about like logic that they write, and a lot of rules are just logic, and so computers are really good at logic. So like there's a sort of advantage to be able to help something that you hopefully get familiar with as you use it more and more, to make you feel more confident that what you're writing actually does what you think it should. So it is incredibly precise language because a computer needs to run it, which means it needs to be always having one result, right? That's the kind of objective quality criteria of a good rule, right? It always gets to one result, and that result might be an error, right? Where the code blows up and nothing works, right? But at that point, you at least know that you maybe shouldn't deploy that yet. So like that's like we call this an objective quality standard, right? Which currently doesn't apply to legislation. Like there is no easy. I mean, every legal drafting office comes up with their own rule book on you know, how to write and what to consider and so on to make a high quality implementation of whatever legislation you're drafting. But there's no, like, it's hard, like there's no traditional quality assurance the way we think about it in industry, right? Where we have a criteria, like this is exactly what needs to happen. Like we have these 2,000 example cases and we know exactly what should happen in those cases. And we want to test that the implementation produces these outcomes, right? That is not necessarily a process in every legal drafting office, and it becomes viable if you use code as a language to help you get to that result. So it's an organic process. I don't think we're working towards a precise future here, because it's also like, it's quite overbearing, I think, to a lot of legal drafters to think, oh, from here on forward, I can only code. That's like, no, I don't think that anybody would want to do this. It's like saying, like, we're not going to talk to each other anymore because it's imprecise, right? No, that's stupid. I think that, you know, the English language will not go away. The drafting of whatever you want to do in English, it's kind of, even if it's just the spec, in industry we call it a specification document, right? Where you write down a napkin idea of your future business, right? I mean, supposedly this is the garage story from Silicon Valley or whatever, where you write down your you know, oh, we do this, step 1, step 2, step 3, profit, right? Because it's very imprecise, but it helps you reflect on what you wrote and so on. So it's not going to go away, but you can then throw this and into an AI system, and the AI helps you generate some code that allows you to reflect and test and verify, move things around, and it will also help you to get back from code into text, if you like, because it is already so close to English. It can produce. Like we actually thought about training an AI model specifically on a style guide, so that you can say, hey, we usually write our legislation in the following syntactic style with the following nuances in English. You know, this grammatical sentence structure is preferred over this one, whatever rule book you might have already in your drafting office. And the AI can take L4 code and sort of make it very similar to that. Obviously, you would need to still review it again to a degree, right? Because again, it's AI, it can make mistakes before you really release it. But the likelihood of it making mistakes when the source document is so specific is much harder, right? So, like there are different paths to the future. I don't think there is a change in the architecture of how everybody works just yet. Maybe it will slowly build up to that at some point, but I don't think it will be tomorrow. For now, it is a drafting tool as well as a deployment tool for us, right? So we can with the life insurance terms, have them implemented in L4 and then deploy them as a API that computers and websites can call in order to figure out if their whatever happened in their life qualifies for a life insurance payout or not, right?
Yeah, thank you.
I'm really interested to know where you're at in your startup journey, Thomas. I have I work with the Cardano community. Cardano built its core protocol in Haskell. So we're very familiar with this kind of functional language. And in your startup information on your homepage for Legalese, you talk about blockchains and you know, bringing the rules across, because that is part of the infrastructure, at least I believe, is going to be very key to governance and government moving forward. So where are you in your journey right now?
We're at the very beginning. I'm not even very deeply affiliated yet with Legalese, to be fair. We're still working out the exact structure and how we want to work within the business and so on. So it's, the language exists, but that was more of a science funded project with a university in Singapore. And so between a few parties, including Michael, we're sort of setting up Legalese to become the business, and we're having conversations with potential customers and doing examples and showcasing and sort of learning and getting feedback from people about what we're doing to help us refine on how we're going to tackle it. I think everybody has the intention to lean into this over time, and it's just the next steps have to fall in line to enable that. But the blockchain specifically, to address it, we currently have this huge crypto conference here in Singapore called Token 2029.
Yep.
And it's it's a whole circus. It's like 850 side events or something. I mean, it's crazy. This week is a very social week. And like what the way we see blockchain, because the blockchain is a distributed network of computers that can run code,
Exactly.
right? And if you have rules and legislation in code and it can run, you know, the API that I was talking about doesn't need to be on a computer in a government basement, right? Like actually, I think code has a lot more weight when it lives on a network of decentralized computers all around the world, because it is essentially tamper-proof from being changed, unless specific actions are taken by the owners to redeploy it and sort of negate it, right? So if you are a government and you deploy your legislation on whatever, a large public blockchain, let's say Ethereum or even Cardano, like, you know, I think it has a lot more authoritative weight because it is essentially unchangeable unless you act again, right? And in a world where AI allows you to clone, copy, create fakes of almost everything, I think it creates like a North Star on what is the authoritative line right now, right? Because it's very hard, if not impossible, for AI to change these things. So they become very authoritative. So I think they hold more weight in the future than anything that is not on blockchain, because I don't know, even if it's a government server, right? Like that means the website is exposed to DNS systems and other things that can be faked and so on much easier in some ways than a blockchain could be. Cryptography is just a brilliant thing in a way. So that's how we see it. So for us, the blockchain is a deployment mechanism, right?
Absolutely.
So when you're done writing your rules, at some point you can choose to print them in a PDF, to deploy them on your computer as a function for other systems to consume and evaluate, or you can put them on blockchain for the whole world to run them. Right?
Absolutely. And cross jurisdiction as well, working on a use case at the moment that is supply chain and real world assets, you know, being tokenized and then the tokens transferred, and there are so many rules and regulations that will actually need to be code in order for us to do this.
A lot of it, specifically, but once you have code, you can evaluate them at scale, right? Like this code can run 1,000 times a second, right? It doesn't need to be a lawyer involved interpreting the language in English and figuring out how this specific case applies. You know, you just throw the inputs at the function and out comes the result. So there are use cases where that's incredibly important to do with precision. And I always say this at legal conferences as well. You only write rules and legislation if you have one of two problems. You need the precision, because it's really important to be precise in this case. And that's why you spend so much effort to define that precision and write it down for everybody to see and read and evaluate. Or you have a problem of scale, meaning you're governing so many people that you can't talk to everybody individually to convince them what the rules should be. So you have to write it down to make it scalable, right? And then everybody can sort of reflect on it and implement it in their own way. right? So if you don't have a problem of precision requirement or scale requirement, you wouldn't write it down. Like, it just doesn't make sense. And in both cases, when you need precision, code is great. And if you need scale, code is also great because it's really cheap to run compared to AI or hiring a law firm to run through it. So that's why we think this is going to be an increasingly useful approach.
Thank you. Thank you. And I agree with Alfred, very well articulated. Thank you very much indeed. Are there any other questions for Thomas today from anybody? I don't want to close us off without giving everybody a chance. Not seeing any more hands go up at this point. Thank you very much indeed, Thomas. It's been great. Learned a lot. Look forward to
glad. I hope if you have any questions or you want to tinker with it, you know, we have this l4.legalese website. We have a Discord server here, which you can join, which is a chat tool, online chat tool. Specifically, the young people love it. But it's open and free to join if you just want to talk to us, have questions. A very useful tool in this editor that we have here that you see on the website as well, with the online editor button on the top right. Is to be able to share code. So you see the share button up here, which creates a unique link that you can copy paste in the Discord or in a chat with a colleague or an email so that they can see and run the same code.
We might put it in the chat because we're not seeing your share screen anymore. But we will, if you could put it in the chat, that would be very useful, because
it's the JL4 like, or the website that is l4.legalese.com. Right.
Beautiful. Sorry, I stole the screen back, Thomas.
No worries.
Cool. So we will put those details straight into the RaC Guild website, and you'll also be able to find the video of this to review on YouTube at RaC Guild, and our next meeting will be the first Wednesday in November. Look forward to seeing you all then. That's the 5th of November, and it's the opposite time zone, which is probably more comfortable for you actually, Thomas, in Singapore. Next month's RaC Guild Town Hall. So thank you very much indeed. Do go and look at YouTube. Go to racguild.org to find details and links to all of the YouTube videos of all of the last 15 sessions. Thank you again, Thomas, and everybody have a great day.